Hi, this is Roopa Prasad, Assistant Professor, Department of Computer Applications, MITS College. So today we are going to discuss about stacks. Okay, in this presentation, we are going to discuss about stacks. Okay, so coming to the contents of this presentation, so today we are going to discuss about the stack, that is the introduction of the stack. Then we are going to talk about the stack operation. Then we discuss the operations that can be performed on stack. Then we go for the stack implementation. Actually, the stack can be implemented by using the static method or by using dynamically we can implement. Then we particularly discuss about the stack, that is the static implementation by using the arrays. So in this one, we are going to discuss about the push algorithm and we are going to discuss about the pop algorithm. Then we come for the applications of stack, and here in this application we are going to discuss about the evaluating expressions and then converting infix expression to postfix expression. Okay, so these are the things which we are going to discuss today. So coming to this introduction part, so what is this stack? This stack is a linear data structure. What we call this stack is a non-primitive linear data structure. So what do you mean by linear data structure? That means the data will be stored in a linear fashion. Okay, so this is one thing we have to remember. Stack is a non-primitive linear data structure. Okay, and what we call this stack? Stack is an ordered collection of items into which new items may be added or inserted, from which new items may be deleted at only one end. This thing we have to remember. That is a significance of stack. That means we can able to insert the data items and we can able to delete the data items, but only from one end. This thing is very important. Only from one end we can able to insert and delete the data items, and that one end we are calling it as a top of the stack. Okay, and this what we are saying is addition and deletion in a stack is done from the top of the stack. That means the last added element will be first removed from the stack. That is the main significance of stack. That means we can able to insert an element and we can able to delete an element, but only one end, that we call it as a top of the stack. So what we are going to say this stack as last in first out. That is whatever the element we have inserted last, that will be deleted first. That means there is only one way. There is only one way for inserting as well as deleting. So the last element which we have inserted is the first element that we are going to delete. So this tag is also called as LIFO, that is last in first out. That is the most frequently accessed element is topmost element, and least accessible element is the bottom of the stack. That is a basic introduction of stack. What we have discussed, stack is a non-primitive linear data structure and it is an ordered collection of data items. From we can able to insert an element and we can able to delete an element, but we can able to insert and delete element at only one end, that we call it as a top of the stack. And this stack is also called as last in first out, LIFO. Why? Because the last inserted element is the first element that we are going to remove. So what we are most frequently accessible element is the topmost element and the least accessible element is the bottom of the stack. Suppose if you want to delete the bottommost element, then we have to remove all the elements that are residing before that element. Then only we can able to delete the last element. That is last in first out. The element that is inserted last will be deleted first. That is a basic introduction of stack. And coming to the stack operations, we have only two operations that could be performed on stack. One we call it as an insertion operation and second one is called as a deletion operation. So see here the insertion this insertion operation is also called as push and the deletion operation is called as a pop. Okay, now this is a stack. Now there are no elements in the stack and we are going to insert and delete element at the top position. So here the top is below the stack element. That means the stack is empty. So we can say the stack is empty or we can say it is underflow if the stack contains no elements. So at this point where the top is located below bottom of the stack. So that is the top equal to -1. That means what the stack is empty, no element is in the stack. So whenever we are going to insert an element, that will be added to the stack and the top position will change. Now we have inserted 20, so 20 is here and top refers to this position. Below that, before that, the top is this position, that is -1. Now the top becomes 0. So whenever we are inserting another element, top will move to the next element. That is, now the top is here. Now the top will become this element. That is top equal to 1. Like that, we are going to insert the elements. Okay. And coming to deletion, and how we are going to delete means we can able to delete only at the top of the stack. Now what is the top of the stack? 47. So when we delete 47, top will becomes this position, that is 33. At this position, top will be located. So when we call the stack is full, whenever the top, whenever the stack, whenever the top points here, we are saying that the stack is overflow. So when we call it as a overflow, when becomes it full, when it becomes full, that is no other elements can be pushed onto the stack. So where the top pointer will be there, top pointer will be at the highest location. Then we are saying that the stack is overflow. Okay, stack is underflow when top is -1, that is below the stack, that is the bottom of the stack. When the top pointer is at the highest position, we are calling that stack is overflow. In underflow and overflow. And coming to the operation that can be performed on stack, we have two primitive operations. One we call it as a push operation, and the one is called as a pop operation. Push means insertion, pop means deletion. We have only two operations that can be performed on stack. One we call it as push and the one is called as a pop. Push means what? The process of adding or inserting a new element to the top of the stack is called as a push operation. That we call it as a push operation. So pushing an element means what? We are going to add a new element to the top. After every push operation, the top is incremented by 1. That is mandatory. We have to move the top pointer so that it points to the current location. So insertion means, that is adding an element, is called as a push operation. So after pushing an element means what? Adding a new element to the top, and after every push operation, the top has to be incremented. If the array is full, no new item can be accommodated, then stack overflow condition occurs. So when the stack is full, when all the locations in the stack is filled up with the elements, then we call it as an overflow. That is overflow condition. Next one, pop operation. Pop operation is nothing but the deletion operation. The process of deleting or removing an element from the top of the stack is called as a pop operation. So after every pop operation, the stack has to be decremented. If there is no element in the stack, then we call it as an underflow. If there is no space in the stack, we are calling it as a overflow. If there is no element in the stack, then we are calling it as a underflow. So these are the two operations. One we call it as a push operation, and the one we call it as a pop operation. Both has to perform the top position, that is a top pointer. So that is a stack significance, that is insertion and deletion can be performed at only one end, that is at the top of the stack. And we see here, so now the stack is empty. Now the top points to -1, that is no element is in the stack, so that we call it as an underflow. So then what we are going to do, you are going to perform a push operation, that is we are adding one element to the stack. Now the top is incremented to 1. Top plus 1. Top is -1. So -1 plus 1, that is 0. Top equal to 0. Now we are adding one more element, that is 33 will be pushed into the stack. So now the top has to be incremented from here to here, 0th position to the first position. And now we are adding one more element, that is we are performing one more push operation, that is we are inserting 47. So the top has to be incremented. After the push operation, the top has to be incremented. So the top becomes from 1 to 2. That is 1 plus 1, that is it becomes 2. Now what is the top? Top equal to 2. 0, 1, 2. Okay, now if you want to perform a pop operation, you are just going to give the operation pop. Then whatever the element in the top, that will be deleted. So what is the element in the top? 47. So 47 will be deleted and top will point to the next location. That is top equal to top minus 1. Here what is top? Top equal to 2. 2 minus 1, that is 1. So top equal to 1, it points to 33. 47 will be deleted. Now if you want to add 77, that will be added to the top. Okay, again top becomes top plus 1. So whenever we are inserting, top will be incrementing. Whenever we are deleting, top will be decrementing. That is top equal to top plus 1 for the insertion push operation, top equal to top minus 1 for the pop operation. So like that we are going to perform the push operation as well as a pop operation. And so what thing we have to remember is at the top position only the element can be inserted, and from the top position only the element can be deleted. Now coming to the stack implementation, the stack can be implemented in two ways. One we call it as a static implementation and the one we call it as a dynamic implementation. And how the static implementation can be done by using the arrays, and how the dynamic implementation can be done by using the pointers. Okay, so static implementation can be done by using arrays, and this is a very simple technique, but it is not flexible. Why? Because means the size of the stack has to be declared prior to the program design, and the size is fixed. After that we cannot able to increase the size or we cannot able to decrease the size. Stack size will be it is limited. So limited means, so whenever you are declaring the array, then only we have to define the size of the stack. Size of the stack has to be declared during the program design, and the size cannot be varied. It cannot be increased or it cannot be decreased. That is only the disadvantage of this static implementation. Then we can go for the dynamic implementation also. So in this static implementation, what happens? Resource optimization is concerned. Resource optimization is concerned. So whenever we have to consider the resource optimization, then we cannot go for the static implementation. Memory utilization will not be good in the static implementation. So in order to overcome this one, we can go for the dynamic implementation. That is, by using the linked list representation, we can implement the stack by using the pointers that we will discuss in the later presentations. So first we discuss this one, that is stack using the arrays, how the stack can be implemented by using the arrays. So first we see the algorithm for the push operation. Here we have only two operations are there. One we call it as a push operation and the one we call it as a pop operation. So first we discuss about the algorithm for the push operation and how the stack is implemented. The stack is implemented by using the arrays. So we are going to declare the size of the stack array. So stack, we are taking this as an array and we are going to declare the size. So here we are going to take it as a one-dimensional array for implementing the stack, which will hold the data items. And then we have to take a top, variable top, which points to the topmost element of the stack. These are the things we have to consider. Then data is a data item that is to be pushed. Now coming to the algorithm. So first what we are going to check whether the stack is overflow or underflow. If the stack is overflow, we cannot able to push another item. So we are going to check for this condition. So what we are going to do, we are going to check if top equal to size minus 1. Size is the end size. For example, stack 10. That means what? We can able to insert 10 elements in the stack. So top starts with the indexing starts with 0. So we are going to use this condition, size minus 1. So what is the size? 10 is the size. 10 minus 1, that is 9. 9 means what? It is on the top of the stack. So we cannot able to push another item. So just we are displaying one message, that is stack is in overflow condition. Is it clear? First we have to check whether the stack is overflow or not. For this one we are implementing this condition. If top equal to size minus 1, then what you are going to say? You are going to say the stack is in overflow condition. Or else what we are going to do? You are going to increment the top. We are going to increment the top. For example, top is at the second location. So we have to make the top as 3 so that we can insert another item. So in this top position, so now suppose top equal to 2. Now what we are making? We are making top equal to 3. At the third position, we are inserting the item that we want to place in the stack. Then that the item will be placed in the stack. That is the algorithm for pushing a data element in the stack, for inserting data in the stack. So for this what we have to do? First we have to check whether the stack is in overflow condition or not. For that one we are going to check the top will be the topmost pointer. So top equal to, if top equal to size minus 1, then we are saying that stack is overflow, or else we are going to make top equal to top plus 1. Then at this top position we are inserting the element stack of top equal to item. Okay, so this is the algorithm for the push operation. Then coming to the algorithm for the pop operation. So here insertion and deletion will be done at only one end, that we call it as a top. Okay, so here we have to check whether the stack is empty or not. If there are no elements to remove, then nothing to do. So what we are going to do means, first we are going to check the condition. If top is less than 0, if top is less than 0, then what it means, the stack is empty, because indexing starts with 0. Okay, if top is less than 0, stack is empty. Or else what we are going to do, you are going to remove the topmost element. So how we are going to remove? Stack of top, what stack of top. So whatever the top is a location, whatever the data item is consisting in this array will be shifted to data variable. Then we are going to make top equal to top minus 1. We are decrementing the top, then automatically the element will be deleted. So this is the algorithm for the pop operation, that is for the deletion operation. Here first what we have to check, whether the stack is empty or not. If the stack is not empty, then then obviously there is an element in the array, that is a stack, that element has to be removed, and we have to decrement in the top. So element can be inserted at the top position and element can be deleted from the top position. So this is the algorithm for the pop operation. So these are the two algorithms for the push operation as well as the pop operation. Okay, and then coming to the applications of stack. Okay, so there are so many applications are there, and one of the application of the stack is evaluating the expression. So evaluating the expression. So what is an expression? Expression is defined by the number of operands combined with the several operators. So expression is a statement which contains the operands as well as the operators, operands and operator. So this expression can be represented in 3 ways. One we call it as an infix notation, another one we call it as a prefix notation, and another one we call it as a postfix notation. So there are 3 notation for representing the expression. For specifying the expression, one is called as infix, and the one is called as prefix, and the one is called as postfix. Infix means what? The operator is in between the operands. Operator is in between the operands. In the name itself is infix. The operator is in between the operands. Prefix means what? The operator is before the operands. Okay. Postfix means the operator is after the operands. So by using these 3 notation, we can express the expression. And so see here. This is an infix notation, what we told. The infix notation is a notation where the operator is written in between the operands. So these are the operands. A is an operand and B is an operand and plus is an operator. So operator is written in between the operands. Okay, that we call it as infix notation. While coming to the prefix notation, what it means, in the name itself say prefix. The operator is written before the operands. This we call it as a prefix notation. This we call it as a prefix notation plus AB. That is called as the prefix notation. And coming to the postfix notation, in the name itself we can say after the operands, the operator is specified. That is, it is also called as suffix notation, or we can call it as a reverse Polish notation. That you have to remember. Postfix is also called as suffix notation, or we can call it as a reverse Polish notation. So how we can return an expression in postfix means these are the operands, and after the operands we are having the plus, that is an operator. After the operands we have the plus operator. So this postfix notation is suitable for the computer to calculate any expression. So how the computer is going to calculate, how the CPU is calculating the expression means by using the expression in the postfix notation. By using the expression in the postfix notation. So and this is a universal acceptance notation. Universally accepted notation for designing arithmetic and logic unit of the CPU. So whatever the expression is there, that has to be converted into postfix. That is the main thing that we have to perform. So an expression entered into the computer. So what the user is going to enter, the user is going to give the expression in the form of an infix. Okay, while it is executing, the infix notation has to be converted into postfix notation before executing the instruction. For example, we have this expression a plus b into c. This is an infix notation. It is clearly, we can clearly observe this is an infix notation. Why? Because the operators are in between the operands. So this is an infix notation. So in order to calculate this one, in order to calculate the values 4, 5, 4, 3, 7 are the values for a, b, c. A is having the value 4, 3 is having the value for b, and c is having the value of 7. So what we have to do means this infix notation has to be converted into postfix before evaluation. That is evaluating the expression. Before evaluating any expression, it should be in the postfix notation. So for this for converting this one, what we have to remember is we have to remember the rule. In mathematics, we have to remember the BODMAS rule. That is a bracket of division, multiplication, addition, subtraction. That is a precedence. So here, check the precedence. This exponential operator, exponential operator is having the highest precedence, and then coming to multiplication and division, these are having the same precedence, multiplication and division. Then the next precedence is a plus minus. So you have to remember this one in order to evaluate the expression. First, what is having the highest precedence? That exponential. And after exponential, we have the multiplication and division. Then we have the addition and subtraction. Multiplication and division is having the same precedence, but exponential is having the higher precedence than the multiplication and division. And addition and subtraction is having the least precedence over the multiplication and division. This we have to remember. Operator precedence. Now, we see how the infix can be converted into postfix. Okay, so there are some rules are there. So what are these rules? First, what we have to do is we have to parenthesize the expression. If the expression is not parenthesized, what we have seen in the earlier screen, a plus b into c. Okay, the expression is not parenthesized. So what we have to do is we have to parenthesize the expression. So we have to parenthesize the expression from left to right. And what is the second rule? During parenthesizing the expression, the operator associated with the operator having the higher precedence are first parenthesized. So how we have to parenthesize means first we have to check the operator. And we have to check the precedence. Okay, the operator which is having the higher precedence has to be parenthesized first. Okay, for example, in the above expression, b into c is parenthesized before a plus b. So what is the expression? A plus b into c. So we have to apply parenthesis for b into c because the operator multiplication, the operator into is having higher precedence over the plus operator. Okay. Then after the sub expression which has been converted into postfix is treated as a single operand. Like that, we have to check every sub expression. Then we can be converted into postfix. Okay. So we see the example. Then we can clearly understand. So this is an expression which has been given in the infix expression, infix notation, that is a plus b into c. So what is the first rule? First rule, we have to parenthesize. So how we have to parenthesize from left to right? But the operator which is having the higher precedence, the operands concerning with the operator higher precedence has to be parenthesized first. So what we are going to do, A plus B into C. So we are giving parenthesis for B into C. Then convert the application. This is an infix. We have to convert into postfix. We have to make the operator after the operands. Okay. So this is treated as one expression, but one operand. So what you are going to do, you are going to move this operand to the, this is one operand, bc into is one operand, so we have to make it into postfix. So a bc into, then afterwards we have plus, that is a postfix notation. This is a simple way of conversion. And we see one more example. So this is expression a plus b plus c plus d plus e into f divided by g, based on the parenthesis you have to do. Okay, so first what we are going to convert, we are going to convert this one from left to right. We have to check b plus c. So what it becomes, bc plus, then we have to check the second operand, that is d plus e, de plus. So this is one operand and this is one operand into f. So what you are going to do, bc plus, so we consider this one, okay, this part, okay, de plus into f. So what you are going to do, you are going to combining this one, de plus f into, after that we are going to move to that side, bc plus, then we are going to use this one. Like this one, we are going to convert into postfix form. Okay, just you practice this one, then you can easily understand. Okay, like this is a form of converting the infix to postfix. Now, so we see the algorithm for converting the infix notation to postfix notation. So this is the algorithm which is used to convert a notation that is written in the infix to the postfix notation. So for this purpose, we are going to make use of stacks. So how this algorithm flows means, for here we are going to take an arithmetic expression called as P, in which we are storing the infix notation, and what is the output, that is a postfix expression that is given in Q. Okay, and the algorithm begins by pushing a left parenthesis onto the stack and adding the right parenthesis to the end of the P, at the end of the P. Okay, whenever we are encountering the stack is empty, then this algorithm will be completed. And then coming to this algorithm, so what we are going to do means, first, what is the first step here? Here we have to push the left parenthesis onto the stack. Okay, and then what you are going to do, you have to scan P from left to right. In P, we have the infix notation and we have to scan the expression from left to right. Then you have to repeat the steps 3 to 6 for each element until the stack is empty. If the stack is empty, that means we have completed the conversion. That is, we have converted the infix notation to the postfix notation. So in the third step, you have to repeat this 3 to 6 are the iterative steps. So what you are going to do in the third step means, here we are going to check the operand. Here we are going to check the element that is going to be scanned. If it is an operand, if the element is an operand, then we are directly adding to the queue, which contains a postfix notation. So if we encounter the left parenthesis, if we encounter the operand, it has to be pushed onto the, it has to be placed in the queue. If we encounter the left parenthesis, then this left parenthesis has to be pushed onto the stack. That means you have to insert the left parenthesis into the stack. Okay, and if we encounter an if we encounter an operator, then what you are going to do means, you have to pop from the stack and add to P each operator on top of stack which has the same precedence as or higher precedence than the operator. So what it means, suppose if we encounter an operator, then what you have to do, you have to check the stack. Okay, if stack contains already an operator, that operator is having the same precedence and higher precedence than the operator that you encounter, that operator has to be placed in queue. Okay, that means you have to pop that operator. Then you have to then you have to push this operator to the stack, that we will discuss in the example. And what is the sixth step? If we encounter the right parenthesis, then what you have to do, you have to repeatedly pop from stack and add to P and add to P until the left parenthesis is encountered. Remove the left parenthesis, don't add the left parenthesis to P. Okay, so these are the iterative steps, and seventh step is the exit. So if we encounter an operand, it has to be added in the queue. Okay, that is the postfix notation. If we encounter the left parenthesis, it has to be pushed onto the stack. If we encounter an operator, then we have to check the stack if there is any operator in the stack. If that operator is having the same precedence or higher precedence, then that operator has to be popped, and you have to add this new operator to the stack. Okay, if we encounter a right parenthesis, then we have to pop the elements from the stack until we encounter the left parenthesis. Okay, so this is the algorithm which is used to convert the infix notation to the postfix notation by making use of stack. So that we will explain with the help of this example. Now see, this is the infix notation where we have stored this infix notation to P. We have assigned this infix notation to P. So what is the notation? A plus B divided C minus D into E exponent F plus G into H. Okay, this expression has to be converted to postfix expression. So we are showing here the stack, the elements in the stack, and we are showing the postfix notation, and we are showing the character that is to be scanned. Okay, so first, what is first step? The algorithm starts by pushing the left parenthesis onto the stack. So we are pushing the left parenthesis onto the stack. And what is the character that is scanned? A is a character that is to be scanned. So it is an operand. So we are going to place it in the queue. Okay, so if we encounter an operand, we have to place in queue. Okay, if we encounter an operator, so plus is an operator. So what we have to do, you have to push it onto the stack. Then we have to check the stack if there are any operators present in the stack. There are no operators. So what we are going to do, we are going to push the operator plus to the stack, and postfix contains as usually A. Okay, and what is the next element that is scanned? That is a left parenthesis. So if it is a left parenthesis, what you have to do? You have to simply, that is the third step, simply fourth step. Simply what we have to do, you have to push into the stack, push onto the stack. Okay, and next, what is a character that is going to be scanned? B is a character, so B is an operand. Simply what we are going to do, you are placing it in the queue. So in the queue, it contains A, B, and in the stack, we have these operators. Now next, what is the operator? Slash is the operator, that is a division operator. So if the operator encounters, we have to push onto the stack. Before that, we have to check any operands that are present in the stack. Okay, now check that. So slash is having the higher precedence than this one, so we cannot remove this one. So if plus is having the same precedence or higher precedence than this operator, then we have to pop plus. Okay, now it is not having the same precedence, it is having the lower precedence than this slash. So what you are going to do, you are going to push slash onto the stack. Okay, so what is the postfix notation? AB is having only AB. Okay, and what is the next character that is scanned? C is the next character. So this is an operand, so directly we are placing in the queue. Then next, what is the next element? That is next character is minus, that we have to place it in the queue. Okay, before that we are going to check the stack. Okay, so what the stack contains? Stack contains slash. Okay, slash is having and minus and slash. So slash is having higher precedence than minus. So we are going to pop slash onto the queue, that is onto this queue expression, and we are going to push this minus into the stack. Okay, so what the postfix expression becomes? ABC divided, that is slash. And what is the next character that is to be scanned is left parenthesis. Simply we are going to push onto the stack. And what is the next character? D is the next character. So next character is the operand. So directly we are placing in queue. Next, what is the next character? That is the asterisk. So asterisk is having, and this minus is having less priority over asterisk. So we are placing asterisk. We are not removing. We are not popping minus. We are just pushing onto the stack. Okay, clear. There we have the divided by, that is a slash is there. Slash is having higher priority over minus. So we are going to pop slash. Then we are going to push minus onto the stack. Now what happens here? Into is having higher priority than minus. So minus is having less priority. So we are not popping this minus. Just we are going to push asterisk onto the stack. Then what is the next character that is to be scanned? That is E. So E is an operand. So directly we are placing in Q. And next, what is the next operator? That is exponentation. Exponentation is having higher priority over multiplication. So we are not popping multiplication. That is asterisk symbol, and we are going to push this exponentation onto the stack. And what is the next character that is to be scanned? F. F is the next character. So F is an operand. So directly we are placing it in the stack. In the postfix expression, that is Q. Okay, and next, what is that one? Right parenthesis, that is a closing parenthesis. So whenever the closing parenthesis occurs, then we have to pop all the elements until we find the left parenthesis. So this is a right parenthesis. Before right parenthesis, what we have? We have the exponential symbol, so that is popped. And next, what is the next one? Asterisk. Asterisk is to be popped until we encounter the left parenthesis. So we encounter the left parenthesis, so we are going to pop up to this one. That is, exponential symbol has to be popped and asterisk symbol has to be popped. Okay, and what is the next one? Now what is left over in the stack? That is a left parenthesis plus left parenthesis minus. Okay, and what is the next operator that is to be scanned? Plus. Plus is an operator. And what is in the stack? What is in the stack? We have minus. Minus and plus is having the same precedence. So we are going to pop minus and we are pushing plus onto the stack. Okay, and what is the next character that is to be scanned? That is G. G is an operand. So we are placing just as it is in the Q. And next, what is next one? Next one is also right parenthesis. So whenever we encounter the right parenthesis, then what we have to do? We have to pop the elements up to we encounter the left parenthesis. So what is up to left parenthesis? What we have? Plus. So we are going to pop plus. Okay, and what is the next one? Asterisk. Asterisk is the next character that is to be scanned. So asterisk is having high priority over plus. So we are not popping plus. We are just pushing plus asterisk onto the stack. And finally, then we have the next one that is called as H. H is an operand. So we are placing it in Q. And next, what is one? Right parenthesis. So whenever right parenthesis encountered, so what we have to do? Whatever the operators are in the stack, that has to be popped until we encounter the left parenthesis. So what are the operators? Into is the operator and plus is the operator that is to be popped. Okay, so this is a simple algorithm in order to convert the infix notation to postfix notation. So what you have to remember is, you have to remember first the algorithm starts with by pushing the left parenthesis onto the stack. Then if the character is an operand, then we don't push in the stack, we just add to the postfix notation. If we encounter the operator, then if we encounter the left parenthesis, then as usually it has to be pushed onto the stack. If we encounter the operator, then we have to check whether there is any operator present on the stack. If the presented operator is having high precedence or same precedence than the new operator, then the old operator has to be popped. Okay, and we have to push the new operator. Okay, and if we encounter the right parenthesis, then we have to pop all the operators until we encounter the left parenthesis. That is a simple algorithm for converting the infix notation to postfix notation. So once you practice this one, you just work out this one, then you can easily understand the procedure. So simply we have to follow the 4 steps. The 4 steps you have to follow in order to convert the infix notation to postfix notation. So you just try this expression manually, then you can easily understand how you have to do. Okay, so this is a reference, that is this material has been prepared by using this textbook. Hope you understand, and if you have any queries, you can give it to this form, and thank you.